In this video, I wanted to introduce to you a new range of interactive components that are part of the iQRite series of interactive systems and solutions. So the new series that we're introducing is called PolyTouch, and it's a range of components that allow you to build your own interactive system and solution in quite a different way to what we've been able to achieve previously. So in the previous times and offerings that we currently have, it's about creating a touch area based around a frame or a foil. And so within those areas, that surface becomes interactive, designed to be used with LCD plasma screens and projection. The new range allows you to create interactive touch hotspots based on use of the components, and they're quite varied in their application and bring about a new range of, I think, exciting ways to create interactivity for your visitors, customers and so forth. So let me introduce the range to you now. So first up is the hub controller. So this is a controller that allows you to connect a range of the input devices and controlled by software via a USB input cable. So once you've set up the software, you're able to interact with the various touch component input solutions. So as you can see, we're able to have 20 inputs on the controller and allows you great functionality. This item is our Capacitance Sensor pad, and what it enables you to do is simply by touching the pad surface, it will cause a contact closure, and you can see there's a small ribbon cable with a connector on the end of it. And the idea is that you could place this behind a paper poster, and for example, if you placed it behind 4 sheets of paper and had a hot spot on that paper, would allow you to actually touch that area and it will cause a contact closure, allowing maybe a light to come on, a video clip to play, or maybe a JPEG photograph to be displayed on the LCD screen. So a very innovative solution that allows quite unique applications. Now this next item is our undersurface capacitance sensor. Allows you to place it beneath a solid surface of any material apart from metal, and when applied to it, the area, which is 30 millimeters by 30 mils, allows that area to become interactive. So for example, placing it behind a piece of 10 mil timber would make that area of the timber surface interactive. Now you can imagine how that can become quite innovative. For example, you have a map on a shop window or maybe a tourist centre. You could place one of these sensors behind a particular city or an area of attraction for visitors, and they could touch that, and then on a screen nearby could be playing a video associated with that particular area. So very simple to use, 3 cables coming in on the connector, and there's a sensor adjustment depending on what is the material that the sensor is having to sense through. In addition, if you were, for example, wanting to place it behind a timber surface but you wanted a larger touch area, well then you would simply apply a foil of the size that you desired with the touch sensor, and that would then increase the touch sensitive area. So again, a very innovative little solution there, and of course you could apply a number of these hooked up to the controller, allowing multiple touch surfaces over a wide variety of installations. Now our next object is called a near field IR object detector. Now a very smart piece of kit this one is, can be used for security applications or communication through interactive touch for customers. So how does it work? Well, first of all, you have a object, and the object could be anything. Could be a item for sale, it could be a demo piece of equipment, it could be a bottle, that sort of thing. So the idea is you place the sensor beneath the object. Let's say this example, it's a bottle, and the bottle's going to sit on a shelf, and so you would place this sensor beneath the shelf, and then you would place the bottle above the shelf. Now the shelf can be made from a variety of materials like glass, wood, a paper shelf, or that would be cardboard I guess, plastic, acrylic and so forth. And so it's able to sense the absence or the presence of the object once it's been calibrated. So if it was a device, for example, that was for sale and of quite high value, you could then set that up, and when it was picked up it might trigger an alert, an alarm, or in fact it might display on a nearby LCD screen some information about the product to give the customer some more informed data, specifications and performance and that type of thing. A very clever way of enabling the whole area of pickup touch to be the trigger for the experience that the customer's wanting. Typically when people pick up something, they're trying to establish more information. Maybe it's the weight, the feel, the look and so forth. And so by their very action, you can take advantage of that and enhance that experience for them. This next item is ideal for installations where you want just simply the motion movement, the passing by of a person to be the trigger. Now, a lot of people may not know that the display they're looking at or standing next to is interactive, or they may not actually be accustomed to interacting with touchscreens and so forth and buttons and what have you, and maybe a little adverse to that experience. So what this does, it creates a invisible infrared curtain, so that as people are passing through that curtain, that will then be the cause for the trigger. Now again, it could play an audio file, it could turn on a light, it could turn on a video to play, any number of sequences of events that you can think of to enhance what is the experience about. So again, an innovative way of creating interactivity without touch. This device is what we call our reflective optical detector. So what it does, it creates a beam, and the beam is then reflected back to the transmitter. And when that is broken, then it will cause a contact closure, which then we feed into the hub unit, and that then will cause something to happen either on screen or in the environment. The beam is able to actually measure 3 meters, so you could put it in a doorway, for example, and so when someone passes through the doorway, maybe they receive a message as maybe a warning, or maybe as a welcome, or maybe a video clip or music might start playing for them. Our next input device is a foot touch switch, and the way that this works is that it senses when someone's walking on the surface, be it a floor, staircase and so forth. And what it's able to do, it's able to measure, for example, a staircase made from stone, ceramic, wood, timber and so forth, metal. It's able to measure the pressure that's being applied to the step as the person is stepping on it. So again, that could be the trigger that's causing audio, something in the environment, something on the screen to be displayed. It's able to measure a sensitivity of up to 300 kilograms. So it provides quite an unusual and invisible means of capturing the input of maybe someone walking up a staircase, and that could be applied to, as I say, video, audio playing. Could be a musical notes as you're climbing up the stairs and responding in real time. This next device is our metal detector. Can be applied in a number of ways, and let me give you some examples. So for example, if you were having a metal object that sits on a shelf, you can actually use the metal detector to know when maybe it is being picked up. And again, that would cause the action to display a video, a clip, lights to change, something to happen within the environment. Or another way of actually using it would be, say, in a game show revolving clock, where you've got an arm that's going to revolve around a circle and it's going to stop somewhere, and wherever it stops, something will happen. Now, if your arrow is made from metal and you have a series of the metal detectors mounted behind the screen, then when the arrow stops on that particular, or above that particular metal detector, then it will cause something to happen, and that could be the flashing lights, a bell ringing, a siren winning. Maybe it's being used for a competition where it has to stop on a particular winning number. And again, innovative way of using the presence of metal to be the action. The next input device is what we call the interactive carpet. So it's a 450 by 450 centimetre square carpet mat that allows the user, once they step onto it, will be able to sense that they're standing on it, and of course that then will apply to the sensor input on the hub controller and will cause something to occur, be it the lights dimming, sound playing, video to start playing on the LCD screen. So again, a very innovative way of combining body step in an area to be the trigger. And of course you could add a number of the sensors together to make a wider area of multiple touch inputs on top of the floor. Now the next two items are very similar and just, I guess, really different sizes and shapes. But basically what we have initially is our LED pad. And so what it is, it's a lighting pad that allows you to place a label on it, and that could be a descriptive label, and mount it into an installation. Now, the interesting thing that this could have on it is a behind the surface sensor, so that when you touch the light, something will happen. Or maybe you might want to use this particular light, because it's very flat, 3 mils flat, that it's placed somewhere that when an action occurs elsewhere that has a sensor input, then the light might light up. And so allowing you to do innovative types of installations using that. Now, a similar item is our circular touchpad. So this would be mounted into a solid surface, be it a table, a wall, and it allows you to use the large circular button as being the interactive surface. Now in itself it is only a mount structure with the lighting embedded in it. And again, by using a sensor, you could then enable touch to be applied to that particular light sensor input. Now these next items are wireless transmission units and a receiver. So now the way that this could work is that maybe you would like to make a cardboard box, for example, to be interactive without wires, attaching it to the shelf and so forth. So what you're able to do is put one of the sensors that we've described earlier inside the box, along with a wireless transmission board powered by batteries, so that when someone now picks up that box and maybe they touch a certain area on that box, then in real time that action of touching a particular area on the box will be wirelessly transmitted some distance to the hub controller, where it will now be processed in real time, making maybe a message to come on, something in the environment that will change, be it a light and so forth. So a very interesting way of creating an experience when maybe you want to have some real magic with no wires being apparent, and or you've got quite a distance between the sensing experience and where the computer and the hub controller might be located. The next product is our ultrasonic sensor. And what it does, it measures a person's distance from the sensor and will cause a trigger switch. A way to imagine that how you could use this. So you have a display, let's say it's an LCD screen on a wall, and you want it to start playing a video clip when a person is standing at a distance from the screen. And so you might want it so that when they are standing within 1.5 meters, the video clip will start to play. When they're standing at 10 meters, it will not play. And so it's an innovative and creative way of using the distance that a person is from a desired spot to be the action that causes a contact closure and something to happen. This next item is also a media player designed for MP3. It comes shipped without a box, so just as a bare circuit board. It is able to read a number of memory devices, and again a very creative way. So you could actually use your presence, a touch action on timber, a presence distance as being the trigger that will cause maybe the volume to go up, the volume to go down, a media file to start playing. And so a very creative way that allows, again, people to interact with the environment and for media, and in this case audio, to play automatically. Our next item is a media player that is programmable. It has a built-in amplifier, external volume control, input connections, and also a line output connection. And so what you're able to do here is to use the input contact closure setting connectors to be the point at which, when they are closed, it will cause a media file to play, being an audio file. And depending on how you name the file, you can add further creativity on what file will actually play. A very simple unit that's made from a metal case, easily attached into an environment by the screw brackets, and allows you to then, when you only need audio and you need it to be automatically playing on a action, then this unit is perfect for that solution. Designed as an industrial unit rather than a consumer type product, and very indestructible and rugged, using a memory card as the source for the media file. Now we also have some accessories to help enhance the experience. So the first one is our serial controller board that allows you to connect up to 16 devices that are triggered by relay contact closures, and they could be driving a piece of equipment, a lighting circuit, any number of objects that can be triggered by simply having a relay on the front end of it. And again, you can have up to 16 units being managed by this, so allowing you to do quite substantially large installations. And again, it's connected by RS-232 to the computer, and the computer via the hub controller is now going to manage all of those contact closures simultaneously. So to help to make all these components work in either a rather simple or very complex type of interactive situation, we have some software that controls the controller unit that actually you don't need to know any programming. It's really just a matter of identifying the media files that you want to play, the input channel that it's going to be, and then by selecting the various menu options, and very simply assign those key commands. So just walking through now the chart that we have on the display. So for example, we have on the left hand side, we've got the above touch sensor, we have the through surface sensor, a foot sensor, body motion sensor. So they're the ones on the left hand side there in the red, green, pink and orange boxes. And then as you can see there, it's connected to the CCU unit, the central controlling unit, which is in the blue box, which is connected via USB to the PC. Now on the PC is the installed software, which is licensed and requires a USB key for running it. Now we can see on the right hand side two categories. We can see in the area marked display, obviously that is for visual and sound, so could be an audio file, could be a video, JPEGs and so forth, that are going to be displayed somehow on an LCD or projection unit. The other area is the serial controller. Now what that's able to control is lighting, could be a motor, maybe a fan, a device of some sort, a circuit that switches on and so forth. So that's the serial controller. So all of these units working together can create a very complex or a rather simple interactive experience. No need to go out buying very expensive computer and touch screens and all of that type of technology, but at the same time still achieve a remarkable experience. Now a couple of the units actually don't even require the software or the hub controller. The capacitance above surface sensor, for example, actually if you just touch that with your finger, that will automatically create a contact closure. So it can actually be used without the system if you want to use it in another manner, and the through surface sensor, simply place that beneath the timber or the surface, whatever it is, deliver power to it, and that will automatically create a switched output. So an example of how you can either use it very simply, use it as a component into another system, it's all possible with that. So hopefully this video has been helpful for you. If you have any queries, questions, opportunities, projects that you're working on and you would like further information on pricing, we'd be delighted to hear from you. This is Kevin from ICEAV. Thank you very much.